Alright, so here's page 2 of our study guide. This one's all on polynomial and polynomial operations. When I see this first problem here, I see a trinomial minus a binomial plus another binomial. So this is a combined like terms problem, but all I have to do before I get started is anytime you see a subtraction in between, I need to distribute that negative to the next parentheses. So I'm going to say this is a plus, and then this positive 3 is now a negative 3, and this positive 5 is now a negative 5. Now I need to go ahead and sort everything out. I'm going to start with this negative 9 into the fourth, and that's because that's my biggest exponent. We like to start with our biggest exponent and go down. So into the fourth is the biggest one. So I'm going to go see if I have any other into the fourth, and right there next to it I have another one. And all I have to do is add my coefficients. I am not messing with their exponents. I'm only adding the coefficients. So I've got negative 9 plus negative 3, and that is negative 12 into the fourth. The next thing I need to look at is the next exponent down. So do I have any into the 3's? Yep, I've got positive 6 into the 3's there, and I've got positive 7 into the 3's right there. So I'm going to say that this is altogether plus 13 into the 3. Just adding our coefficients again. Now I'm going to see, do I have any squareds? Yep, there's a squared, and I have no other squareds here. So I'm going to go ahead and just bring that right down exactly as it is in order. So this is called descending order when we put it from our highest exponent to our lowest. Last thing, I have some constants. That means a number without a variable. So I can just add those together as well. So positive 2 plus a negative 5, that is negative 3 altogether. And there you go, that one's done. This one's actually a little bit simpler, but when I go to distribute my subtraction in between, I come to a positive and then a negative. So this negative is going to become a positive 3x, and this negative 9x is going to become a positive 9. Now, same thing, we're going to start with our highest exponent. I see it x to the fourth, and that's the highest. So I'm going to go grab that and see if I have any others. There's another. So my negative became a positive here. So that's positive 9x to the fourth and 4x to the fourth. And altogether that would be 13x to the fourth. Next step down would be the positive 5x cubed here. Any other cubes? There's another one. And we can add those together as well. So that is positive 3x cubed. Notice if I start with a cubed, I end with a cubed. We are not messing with exponents. Last step, I'm looking at squareds. None of them. The only thing I have left is this positive 3x. I kind of wrote through it a little bit, but that's still positive 3x. I'm going to stick it at the end. And there you go. All done again. Our next one right here is an addition, so it's a little bit shorter. I've got 4g here, 3g there, so that is 7g. Then I have negative 2 and positive 3, so that is still plus 1. So 7g plus 1. Last one, I've got an x squared. That's my biggest exponent, so that's where I'm going to start. So 2x squared, and there's no other, so I'm just going to bring that down, just putting it first. Then I've got 1x right here, and negative 3x is there, so that's negative 2x's when I add the coefficients together. Now I have a negative 7 and a positive 1, and that is negative 6. So it's all done. Now I'm going on to multiplication. Now I know these are multiplication because I have parentheses and another set of parentheses and nothing in between, so that must be multiplication. So what I'm going to do first is you have a couple ways you can do this. I have a binomial times a binomial, so you can go ahead and use a 2 by 2 box and put each of those factors on the outside. So x minus 3 going down the side, and 6x squared, and positive 5 up the top. I'm going to multiply each of the corners into each of these sections of the square. So that's 6x squared times another x. When you multiply variables like this, your exponents are adding together. So that's why we end up with x to the third. If I could draw you a picture, x squared looks like x times x. And then we're just saying times another x. So a better way of saying that would be x cubed. Now I've got 5 times this x over here, so that is 5x. I've got this negative 3 times that 6x squared, that's negative 18x squared. and negative 3 times the 5 is negative 15. Now check your diagonal to see if there's any like terms. That's where they'll always show up. But on this one we have an x squared and an x. Those are not the same thing. So we're just going to write this out. 6x cubed minus 18x squared. I skipped down to here because that's my next smallest exponent. Remember, descending order. And then plus 5x and then minus 15. And there you go. All done. Next one, I've got a 2x minus 3 squared. This is a binomial squared, so I can't give out that squared at all. I'm going to have to write this twice. 2x minus 3 times 2x minus 3. Now I can go ahead and do kind of the same thing over there. The other way you can do it is to FOIL, so you can do your double distributive if you prefer to do that way instead. I'm going to show with the box though. I've got 2x and negative 3 on both sides. So when I multiply this together, I get the 4x squared. I get the negative 6x. I get another negative 6x. And then finally, negative 3 times negative 3 is a positive 9. Here we are actually seeing some like terms on the diagonal, so we're going to add those together. Remember, when you add, you don't mess with exponents. So that's going to be 4x squared minus 12x plus 9 when we're all done. So negative 6 plus negative 6 is negative 12x. We have a couple more. We got 2 more down here. This one trying to confuse you with the variables, but otherwise it's a pretty simple problem. It's a binomial times a binomial again, so 2 terms and then 2 terms. So I'm going to put that on the sides of my 2x2 box. So you notice these look like factors, and this is when we start factoring, this is where our factors end up. So I've got the 7n in the end, that's 7n squared. So our exponents are adding again. I've got negative 6b times an n. We're just going to write that in alphabetical order because we can't multiply that n and that b together. Then down here, I'm going to have 7 times 2, that's 14, and then b times n again. So we're seeing like terms come on that diagonal. And then I've got 2 times negative 6, it's negative 12. A b times a b is a b squared. So we're going to put these like terms together and say 7n squared. Oops, I'm going off screen there a little bit. 7n squared. 14 plus that negative 6 is going to be 8bn. And then we've got that negative 12b squared. Watch out, I almost lost my negative there because I wrote through it. And there's your answer. One last one. It's actually just a little bit simpler because it's not a FOIL problem anymore. So not a binomial times a binomial. This one is just a monomial times a binomial. So this is really simple to just distribute it out. So we've got 4x y squared times another x. So that's going to be 4x squared y squared. And then we've got that minus in between coming down. And then we've got 4 times 5, that's 20. My x follows, and then y squared times another y cubed. This is going to be y to the 5th. Remember, if I can draw you a picture for that, that's y times y, that's y squared, times y times y times y, which is y cubed. So really we have 5 y's all together there. Now we don't have any like terms because all of our exponents are different, so we're just going to stop right there. All right, well that was page 2, and that was all of our polynomial operations.